everyone, in this video we are going to determine the distance between 2 points using the distance formula. So this is the first part. I will put the link of the second part in the description box below. Given 2 points, x sub 1, y sub 1 and x sub 2, y sub 2, the distance between these 2 points can be computed using the equation right here. So distance is equal to the square root of quantity x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. Now, others may ask, how did you get this equation right here? There's another video that talks about how the distance formula is derived. I will put the link of that video in the description box below. So let's take this first example right here. Determine the distance between points K and W. So point K is negative 3, 4 and W is at 5, 4. So we're supposed to determine the distance between them. So using the formula right here, so the first step that we are going to do is to label the given points as, we can take this as the first point and the second point. That means all the subscripts for K would be 1 and all the subscripts for W would be 2. So I can label this as x sub 1, y sub 1, and x sub 2, y sub 2. So once we label them, step 2 is to plug this into the equation that we have over there. So that would mean that our distance is actually equal to the square root of, again, we plug it in, that is starting from x sub 2. So x sub 2 is 5. So I go ahead and write 5 minus our x sub 1 is negative 3. So I'm going to write negative 3 right there. And that's a squared plus our y sub 2 is 4. So I'm going to write 4 right here. And that is minus. So y sub 2 minus our y sub 1 is 4. And there's a square on this parentheses. So then we can go ahead and simplify this. We remember that if we have 5 minus negative 3, we can actually change this to plus and plus. So that means this would come out 8 squared plus this is 4 minus 4 is 0 squared. So then this would come out the square root of 8 squared is 64 plus 0 squared is 0. So pretty much our answer to this is square root of 64, which is actually 8. So then I can go ahead and write the distance between point K and point W is 8. So that because the square root of 64 is 8. So then from here, we can actually test it on the graph that we have over here. So if we were to plot point K, that's negative 3, 4. So negative 3, then up 4. So this is our point K. And then our point W is on 5, 4. So that's 5 and all the way up to 4. So that means it's going to sit here. This is our point W. Now, if we determine the distance between these 2 points by counting the spaces in between them, we can go ahead and count 1, 2, 3, 4, 5, 6, 7, 8. So the distance is 8 units, and it's the same thing as what we did that we have, what we have solved over here. So the graphical solution and the algebraic solution are the same. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, our first step is to label the given points. This will be our x sub 1, y sub 1, and this is x sub 2, and this is y sub 2. And then after that, the second step is to plug this into the equation. Again, the distance formula is the square root of, that is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So then we just have to plug in these values here. So we start with x sub 2. So x sub 2 is 1. So I'm just gonna put in 1. And then x sub 2 is 1. And then x sub 1 is negative 5. So that's a minus negative 5 squared. And then that's plus our y sub 2 is negative 1 minus our y sub 1 is negative 9, and that is squared. So then from here, we can go ahead and change this to plus and plus, and then this is plus and plus. So that means we have the square root of 1 plus 5 is 6 squared, plus negative 1 plus positive 9 is a positive 8. And then that is squared. So then from here, we go ahead and simplify this. 6 squared is 36 plus 8 squared is 64. So then we have, that's the square root of 100. And the square root of 100 is 10. So the distance between these 2 points, Q and R, is 10. So that's 10 right there. So let's put this inside a box. So that's value is 10. Now if we graph this, Q is negative 5 and negative 9. So negative 5 is right here. And then that's negative 9. It's going to be down here. So this is point Q. And then we have R is 1 and negative 1. So we go 1. And then that's a negative 1. So it's going to be right here. So this is our R. So the distance between these two points right here from Q going to R would be 10. So that's 10 units right there. Did you get 10 as your answer to this? Good. Perfect. Now let's move on to the next problem right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to label the coordinates. This would be our x sub 1, y sub 1, and this is x sub 2, y sub 2. And then the second step is to plug these values that we got here, the label that we did, into the distance formula. So again, the distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So then we plug it in. We start with x sub 2. So x sub 2 is 4. So I'm going to write 4 there minus, that's a negative 2 for x sub 1. So that is minus negative 2. And then this is squared plus y sub 2 is negative 1. And then y sub 1, that's minus. Y sub 1 is 3. And that's squared. So then we can go ahead and simplify this. Remember, this becomes a plus and plus. So that would be negative. That's going to be 4 plus 2 is 6 squared plus. That's going to be negative 4 squared. So we simplify this some more. So we have 6 squared is 36. Plus negative 4 squared means we multiply negative 4 twice. So that would be negative 4 times negative 4 is a positive 16. So then from here, we can go ahead and simplify this. 32 plus 16 is 52. So that's the square root of 52. Now, we can actually simplify this. There's another video that talks about how we simplify radicals using the one with the square root, how to simplify square root using the factor trees. I'm gonna put the link of that video in the description box below. So we start off with 52 right here. So we're gonna find the prime factor. So 52 can be divided by 2, and that would be 26. So, and then 26 can be divided by 2, and then that is 13. So these are the prime factors. So then we can go ahead and say that square root of 52. So it's going to be square root of 52 is actually 2 times 2 is 4 times 13. So 4 times 13 is 52. Now, if we break this down, we can go ahead and say square root of 4 times square root of 13. And then we know that square root of 4 is 2. So then we can go ahead and say that the distance between point R and M is actually 2 square root of 13. So this is the distance between these 2 points. This 2 squared of 13 can also be represented in decimal. If we use our calculator, this would be 7.21. So if we were to graph this, we start with negative 2, 3. So negative 2 up 3. So this is point R. And then point M is 4, negative 1. 4 and then go to negative 1. So this is M. the distance between these 2 points, R and M, is 2 square root of 13. So pretty much this can also be represented as 7.21. Okay, did you get the same answer as this? Good, perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!